Well, hello everybody, and welcome to Digital++. In this episode of Building a Metaverse, we will look into grabbing objects in our multiplayer VR Unity projects. This topic was requested by a couple of my subscribers, so a special shout out to these guys over here. And this video is therefore dedicated to you guys. We will implement not one, but two very different ways of grabbing objects. And that's because in our project so far, we have both a first-person mode and a third-person mode. And grabbing objects is quite a different experience in both of them. So just build them both and you can pick whatever you like or keep both of them. This will bring us to the completion of the vendor-agnostic multiplayer baseline, but it doesn't mean that this is the end of the building a metaverse videos. There's still a lot of cool stuff that we need to do and that we can do to build out our metaverse. As we said in the intro of part number 6, we continue to boldly go where no man has gone before. If you haven't attended part 1 through 6 of my videos, you should still be able to follow along if you're building your own project. But of course, I would really appreciate it if you would watch my videos and even better, subscribe. So that really will help me ultimately to make more content. As always, we will start with research and design because I really want to explain the how, but even more the why. And if you're not interested in that, you can just skip right over to the build sections in the timeline. Now, let's roll up our sleeves and get into the weeds. So, what about grabbing objects in OpenXR? Now, grabbable objects need to have a collider and a rigid body component so that we can detect collisions and also detect physics events. Now, grabbable objects must also be network enabled to make sure that they're available all over the network and synchronized. So that means you need to add a network object, you need a client network transform, and you need a network rigid body, which is a special one to make sure that the physics are also replicated over the network. All of those you need to add to your grabbable object. Now, fortunately, OpenXR has integrated grabbable support. For that, you need to add an additional XR grab interactable component. And your controller's hands will have an XR direct interactor. Now, we already use our prefab from Unity, so that already has that configured. So that's all cool, and we can leverage that. Now, not unimportant, you need to bind the events to the XR direct interactors. And how that's exactly done, I will show in a bit. But remember that you need to ensure that there's an event handler connected to your onSelect entered event and on your onSelect exit event. Now, I personally found that grabbing any object with your hands, so not your controllers, but with your hands gestures, does not work if you run standalone on Quest with the Android platform. Now, only the server can spawn network objects. That's something that we learned in one of our first videos. All network objects can have one owner, and only the owner can move the object. And also, the server is the only one that can change ownership. Now, that implies that everything that's spawned by the server by default is owned by the server. And here's the thing. Being the owner of an object does not mean that the object automatically moves across the whole network when you change its local position, even though you have a client network transform. In all honesty, I haven't really found a right way to move an object once you're the owner of it, and we'll come back into that in a little bit. Taking ownership or moving an object does require a server RPC call, and what that does is you ask the server to execute something on your behalf. Now here's a conundrum. Only the owner of an object can request the server to change the ownership. So that's a bit weird. So I want to grab a cube, it's not mine, but I can't ask to get ownership. Fortunately, there's a workaround, and that's you can use a server RPC call with require ownership is false. Now, network context, what is that? Let's talk a little bit about it. So in our design, when part 1, if you remember that, we said we are going to not replicate the XR origin object over the network, but the avatar. So we put a border around what we call a network context, and that means that everything within that dotted line box is known in the network. So every avatar has a network ID, every cube or whatever you want to grab has an ID, even the server has an ID. The XR origins or the XR rigs do not have a network ID. So these XR origins in our design do not exist in the network context. The network manager has no clue what my XR origin is. And this is a couple of situations that I tried out to try to understand how taking ownership and moving objects in a multiplayer VR environment would work. So we start with a grab event, and then what happens is there's an event handler. I grab something and there's a collision detection between the cube and my XR origin. So, okay, cool. My XR origin now sends a message to the server and asks the server to change ownership of the cube. But the cube says, all right, I have no idea who you are because you don't exist in the network. So that's a dead end. Then I tried something else and said, okay, well, again, we'll have a grab event. And I'm now going to ask the avatar on my behalf to send that request over to the server. All right, so the avatar sends the server RPC to change ownership of the cube to the avatar, the network ID of the avatar. And so that goes over. And yep, the server says, fine, owner ID changed. So I can check, and I'm now the owner of the cube. Awesome. So let's send the position and the rotation via the client network transform. But unfortunately, the cubes only move locally. And as soon as I release them, they immediately return to their original position. So again, dead end. Now what? All right, so maybe we could do something with another call. So let's try to follow a very similar approach. So we have an event. The avatar is going to ask the server to take ownership. Yeah, all great, perfect. And now I'm sending my position and rotation via another call, which is called try commit transform. So that's something I found online. Documentation is very poor there, in all honesty, so I couldn't really find a good example either. And so try to send that out. Unfortunately, the cube only moves locally and returns to original position after release. And you already know the drill, a dead end again. Because I really couldn't find any right documentation on how this should work, and I have a very good hunch that this should be the right way to do it, and this try commit transform should replace the client network transform. So the only other way I could figure it out is to explicitly ask the server to move the object on my behalf. And that's the way how I implemented my solutions. And that's the way you will see this implemented in these videos. So we have an event handler, very similar again. The event handler calls the avatar, and then the avatar sends a server RPC not to change ownership, but dear server, here's a cube. Can you please move this cube to the position of my hand or my controller? And the server says, sure, that's fine. This is the way I could get it to work. So talk a little bit about network traffic. As soon as I'm the owner, my client network transform updates the cube position and the rotation to the server, which then sends it over to everybody else on the network. In the alternative that I'm proposing here, which I call the move network traffic flow, I'm sending a server RPC to the server to change the cube position and rotation, which then on its turn also, anyway, sends the traffic to all of the other clients, but it also sends back the client network transform to yourself. So that's a little bit of additional traffic, but it's not significantly different, and therefore it looks like taking ownership doesn't seem to be absolutely necessary to make this work. So let's look at some design topics that we need to agree on before we start digging into the code. So spawning objects. We know that the server will spawn all objects. So we'll create a table that will spawn all the objects via a spawner component script that we create ourselves. And we can, with that, configure also the number of objects via the Unity UI. The spawned objects will be cubes, but could be anything. These cubes will have a box collider. We will turn off the is trigger because they need to have some gravity and kinematic and physics. That's more fun. And we'll have a rigid body for each of these cubes. And we could use is kinematic, but we can also turn it off. But we definitely want to use gravity. Otherwise, you'll have floating cubes, which can also be fun. Well, it's up to you. During the grabbing state, we want to make sure that the grabbables are kinematic. And that's because once you've grabbed them and they still have a box collider active, you start moving them around, that box collider starts to almost create friction between your hand or your avatar and the object itself, and you get really weird effects. We will make sure that we have a grabbables layer. So for example, the table we don't want to be able to grab, so we make sure that's not in the grabbables layer, so you cannot accidentally pick that up and create all kind of havoc. All right, as said, we will going to create two grab approaches. And the first one is the first person, and the second one is the third person. So in the first person view, we will connect the cube once it's grabbed to the controller. We will make sure the avatar is invisible. We'll use the OpenXR grab interactables and the standard solution that's available by OpenXR. And we want to make sure that the XR hands and controllers are active. And yeah, the objects will be bound to the hands and the controller. So it really naturally feels that you grab them yourself in first person mode. Obviously, all the remote clients, they will see your avatar grabbing the object. And for that, obviously, we need to make sure that the offset of the avatar is 0, 0, 0. In the third person view, we will want to have the avatar to grab the object. So the avatar will be visible locally, but the XR origin is inactive. So you cannot accidentally grab an object with your XR hands or controllers. We will create a homegrown grab component just for the fun to see how that would work. And we will use an avatar offset, which we already had defined in our previous episodes, which means that the avatar is about 3 units ahead of you. But you could make it whatever you want. And then the grabbed objects, as I said, they will connect to the hands of the avatar. So it also means if you want to grab something, you will need the avatar to move up to that grabbable and pick it up. It's not your XR controller hands anymore. Now one level deeper. So in the first person mode, we want to turn off the avatar skin mesh render. That will technically make the avatar invisible. We do want to make sure that the hands and the controllers are visible. And we want to create what we call an XR grab event handler component. That's the child of the XR origin. And it receives events from the XR direct interactors and send those to the avatar. And obviously to do that, it needs to have a link to the local avatar. Let's assume there's 10 people in your metaverse. There will be locally on your VR system 10 avatars. So how does your local XR system know which avatar is yours? So you need to store a link of that. And in the humanoid network player, we will make sure that we add a couple of things. We will want to have a couple of links of any objects that we grab by either the left or the right hand. And then in the update function, we want to make sure that we send the server RPC calls to create updates. Now on the third person view, which is quite different, we will turn on the skin mesh renderer for the avatar, but we'll turn off the direct interactors for your XR hands and controllers. Then we need to add a box collider to the avatar, both on both hands, and I decided to connect them to the XR hand IK targets. And for those, I've turned on the is trigger to make sure that you don't interfere with any physics of the cubes. I added an attach point object to each of the hands, and that's a child of the XR hand RK target. So the left hand or the right hand RK target. And the attach point object allows you to very accurately identify where on the hand the object should be attached. So if you don't do anything, the object will be right in the middle of the palm of your hand, so it will cover your whole hand, which is weird obviously. So you want to position it a little bit outside your hand. And last but not least, we need to create a new object, which I called avatar XR grab, for both of the hands. That checks for collisions, that checks for grabbed and release state of the objects. On collisions, checks on the XR hand controller for events, so which button has been clicked and whether or not you do a pinch or a grab pose. And then actually calls the server RPC to the move grabbed object. And this replaces the OpenXR standard grab capability that's there, but it's basically our own homegrown solution. And then there's some stuff that applies to both first and third person. And so in a humanoid network player, there's some generic grab code. We obviously need to have a function that switches between first person and third person mode. And then we have some helper functions that will turn off or on objects for both of these modes. Now, collisions. So once you want to build a grab solution yourself, you have to deal with collisions. And this is the table that is created and available by Unity on their documentation page. So on the top half of the matrix here, you will see all the opportunities to have direct collisions between collider objects. There's actually only a very limited amount of options that you could use. So that's why I said, well, let's make sure the hand is a trigger. So we can look at the lower bottom, and now you see there's many more yeses there. So if one of them is a trigger, and we know the hand is a kinematic rigid body with a trigger, then technically the grabbable could be anything. So you could use a static collider, it could be a rigid body collider, it could be a kinematic rigid body collider. And it could even be triggers, right? So even if you decide to go for a trigger as a box, that would still work. I'll move myself out of the way for a second. So for third-person collisions, we will use the on-trigger event instead of the on-collision event to detect a collision. All right, so the first thing that we will do is we will create a new folder. In the project pane, we'll do plus folder, and we call that resources. The resources folder is a folder that you need to spawn any resources during at runtime. And then we go into the hierarchy pane and we create a new 3D object cube. Position that to 0, 0.53, and the scale will be 2, 1, 1. We go into our materials folder, we create a new material. We call that table material. You can make it anything you want, but for now we'll just make it blue. Then we drag drop the table material onto our table. And we then need to rename the cube to table and add some components. First of all, we want this thing to be available in the network, so we'll create a network object. So the table has a network object ID. We want a box collider, that's already there, so that's great. It should not be a trigger. Box collider is good. We want to have a rigid body. The mass, we will make it 1000, so it should be really heavy. Then we want to create a new object, and we'll call that Grabbable Creator. That's a new script, so we create and add that script. We want to open the script. First thing we want to do is we make it network behavior. We need to add using unity.net code. Let's remove start and update. We won't need those. So we want to have a serialized field, private game object array prefabs. We also want a serialized field, private integer max objects to spawn, and we'll make that 5 for now as default, and then create a new public void spawn grabbables. First of all, I want to spawn the objects. Right, so if you're a host or if you're a server, and that's because in the network only the host can spawn objects, we can do debug.log spawning max object to spawn plus objects grabbables. Okay, so we'll create a vector2. We call that placement area minus max. So then we say placement area minus dot x is transform dot position dot x minus transform local scale x divided by 2. We create an area of exactly the top of the table so that all of the objects will be spawned on top of the table. And now we can copy paste all of these. I'll copy paste it 4 times. So this is the max, max.x, and then the min.y, max.y. This is the z position, scale z, and this should be +2, and that should also be +2. We're creating an area of exactly the surface of the table. So now for int I is 0, I smaller than max object to spawn, I++, game object, instantiate prefabs, random.range 0, prefabs.length, comma, vector3 at 0, turnion.identity, prefabs.length. Okay, missing something here. There you go, that's better. And then we're going to set the position. go.transform.position is new, vector3 random.range, placement area minus .x, max.x, comma, transform.position.y plus transform.local scale y divided by 2 plus game object.transform local scale y divided by 2. So we create the new vector3. The x position of the vector3 will be the random range of placement area minus x and max x. The y position will be the transform position.y plus the half of the local scale of the cube. And then finally the z position of the cube will be a random range between the placement area minus and the placement area max. I made a typo here, so this needs to be y obviously, and now it makes more sense. Cool. And then once this all is done, the last thing we now want to do is go.getComponent a network object and we want to spawn that. And now we go back to Unity and we move the table into the resource folder. So with that you created prefab and we remove that table from the scene. So let's go to Canvas Launch UI and open the Launch UI script. In the host button click, after we start the host, we want to add some code to add the grabbables. So game object spawner resources.load. And we want to load the table as game object. And here's why the table needs to be in a resources folder. That's why you can then use the resources.load function. And the resources.load function can only load from a resources folder in your assets. So that is done. Then game object go is an instantiate. The spawner object position turn on. So object spawner position obviously doesn't exist yet. So what we want to do here is add a serialized field, and that should be a vector3. So now in the UI, we can add position of where the table needs to be located. So now what we need to do is do a go get component network object spawn, and then last but not least we want to make sure that the table is spawned, and with that we want to spawn the grabbables. You see here we now have the object spawner position, so we'll move that to 2, 0.5 and 3. In the resources folder we will now create a new 3D object hierarchy. Create 3D object, a cube, and then the size will be .1, .1, .1. Then we want to add a layer 3, which is not used here, grabbables. We should select the grabbables layer here. Then we create a new material. So let's go to materials and we will create a new material, cube material, and we'll make that a nice red color. And then we'll drag drop that cube material on the cube. We will add a rigid body. We want to check the box collider. Let's make sure the is trigger is off. And then in layer override include layers, we need to put in grabbables. Then we add a component, XR grab interactable. So that is the OpenXR grab system. Let's make sure the movement type is instantaneous. If you look at the colliders field, let's open that. We click on plus here. We drag drop our box collider onto the colliders field. So that's now connected. This is obviously a network object because we want to make sure that this one is replicated over the network. Client network transform. Let's turn off scale XYZ. You could turn that on later on if you want to resize it. One thing you want to do here is turn off interpolation. The way we will implement the grabbing, if you put interpolation on, it's going to seriously lag, and we don't want that. So let's turn that off. And then last but not least, we need to add a network rigid body to make sure that the physics are also replicated over the network. And if you haven't done so yet, rename the cube to grabbable cube. That is done. We'll drag the grabbable cube in the resources folder and we will remove it from the scene. Now let's open the table again, and in the grabbable creator script you have a prefabs. Click the plus and create a new element, and now we drag drop the grabbable cube in that field. Now we're not fully finished yet, so if something is not defined in the network manager, then it doesn't exist on the network. So let's go to the network prefabs list. We currently only have the avatar, so we'll add two things. First of all, we'll have to add the table, and we want to have the grabbable cube. So that's also a network object. And we'll start. All right, host button is on top here. So you see we have our table, and we now have 5 cubes, that network objects, and we can move those over the network. Perfect. Great. Let's go on to the next step. And as I said in the design slides, we're going to implement 2 ways of grabbing, the first person grab and the third person grab, and they're very different experiences. So let's start first with the first person grab, and that will use the XR grab interactables. So let's open our prefabs and we go into the humanoid avatar, and let's open the humanoid network player script. In the class definition, let's create a network object, and we call it avatar left grabbed object and avatar right grabbed objects. If these are 0, then you haven't grabbed anything. If these have actually a network object connected to them, then you know that your hand has grabbed something. And we also want to have a toggle. So this is a toggle that indicates whether or not we are in first person or third person mode, and it's just easy to have. Let's save this. It's just a tiny bit. We're now going to jump back into our application. The first thing we want to do is we open the XR origin we're going to add a component that captures the grab events, and that component then passes the events on to the avatar, which and on the behalf of the avatar can do a server RPC. So this is the non-networked side of the fence. So we'll add a component and we'll call that XR grab event handler. Okay, that's a new script. Let's open that. So let's move that into the script folder. Let's open up the XR grab event handler. This can be mono behavior because again, this does not run in the network context. We don't need start and update. We only need 4 functions. Let's start with that first. So the first thing we need is a few variables. So we'll ulong avatar network object ID, and we want to have a public game object avatar object. So these will be holding the link to the avatar. We'll fill that information in a bit. So we're going to create a function. We call it public void select left grab enter event controller select enter event args. So it won't recognize that. So let's add XR interaction toolkit. And what we'll do is we'll create a variable. We want to know what the grabbed object is. And how do we get that? Well, we will get that from the event args, and it has an interactable object and as well as an interactor object. But the interactable object is the object that you are touching. So in our case, this would be the cube. So the interactor object would be the hand. Okay, interactable object, transform, get component, network object component is. And then what we then want to do is we want to say that the avatar object get component, and we want to have the humanoid network player. And from that, we want to know what the avatar select grab enter event hub, and we'll call that with the grabbed object, and we'll call that with true. And so this will still cause an error. So let's comment this out for a second. We'll have to create this in the humanoid network player. And here we're basically saying, well, if you get a grab event on your left hand, then pass it on to the avatar. And we haven't defined this in the avatar yet. We'll do that in a second. And now we want to copy paste this a couple of times. And now it's not the enter event, but it's the exit event controller. And now we copy paste these two again 2 times, because this will be for the right grab event and this would be for the right grab exit event. The exit event obviously doesn't need to be a select enter event, but it should be a select exit event args, and then the same here for this one. So there should be a select exit event arg. So let's change those, then save it. So the next thing we want to do is we want to go to our XR origin, and we open the left controller and the left hand. From both of them, we look at the direct interactors. The direct interactors will have an XR direct interactor component. Open up the interactor events, and then you go to select entered. This list is empty, so let's create one. We go to editor and runtime. It's by default assets, but click the scene tab. We now do XR origin. You see this gray bluish icon here. That's the one you need to have. Let's click that. And then we go to drop down field here. And then we say XR grab event handler. And we have select grab enter event controller. Awesome. Let's add that here. So now we've connected the XR grab event to our event handlers. And we'll have to do the same for the release event. So we'll create an entry here. So let's select editor and runtime. Then in the scene tab here, we find the XR origin. And then under function, we go XR grab event, and there should be a XR left grab exit event handler. So this is the enter event handler, and this is the exit event handler. Perfect. And we want to do the same for the right hand. So we open right controller and the right hand. We select both the interactors by pressing the control key. We go to the XR direct interactor, the interactor events, and in the select entered, we click a plus. We go to editor and runtime. We go to scene, we do XR origin, the grab event handler, and we have the right grab enter event controller. And now for the exit, we'll need to do the same. We'll do editor and runtime, scene, XR origin, and the right grab exit event controller. Perfect. So what we've just done is binding the interactor events or the grab events to the XR controllers. This is just the non-network context side of the fence. We now need to go into the humanoid network player and make sure that we have a function that we can call and that actually will do the server RPC. Let's go into that now. So back in the humanoid network player script, go into the on network spawn function. And then here we have a piece of code where we are checking for the XR origin. What we now need to do is make sure that we do the myXRRig get component, and that's the one that we just created. So it's the XR grab event handler. Avatar network object ID is my ID. And we need to have the avatar object, and that is actually the transform.game object. This is the link to our own game object. So now we can always directly from the XRRig identify which is the corresponding local avatar. Then at the end of null network spawn, the FP3P toggle is third P toggle is on, then it's false, and otherwise it's true. To capture first person, third person toggle changes. We'll use that a bit later on. Now we go all the way down to the null network player script, and at the end, we'll add a couple of methods, and we'll call this one public void avatar select grab enter event hub. Let's let enter event hub. And it needs to get a network object link and net obj, and it needs to get a boolean. Which hand are we using? The boolean should be true if it's a left hand, and it is false, then it's the right hand. So we need to now tell update to align the grabbed object to the left or right hand. And so how do we do that? We say, well, if which hand, that's true, then the avatar left grabbed object is net obj. And if not, then the avatar right grabbed object is net obj. Now we're only telling the avatar that we have something grabbed in the left or in the right hand. We can do a debug.log first person grab object net obj network object ID. So now we can get a debug message that we started grabbing something. And then something very similar. So we want to do a public void avatar select grab exit event up. And for this one, we only want to know which hand that is. Debug.log. We'll do a first person release. If which hand is true, then we say that the avatar left grabbed object is null, because we no longer grab something, otherwise the avatar right hand object is null. Last but not least, we want to create a server RPC. So this below here only runs on the server context and not on the client. Public void move my grabbed object, and then it's a server RPC, so it always needs to end with server RPC. We want to have a network object reference, grabbed obj, and we want to have a position, because we want to obviously know where we want to move it to, position, and we want to have the rotation. If you're not a server, then return, because this only needs to run on the server. And then if grabbed object try get, so you're trying to get that reference, and then we're going to get that into a real network object, because the other one was only the reference network object. So now the net obj should be referring to the actually grabbed object. Net obj dot transform dot position. We now want to make that the position, and the net obj dot transform dot rotation is the, and then we do a debug.log. Now the next thing we want to do, add another server RPC. It's a public void set is kinematic server RPC. We're going to ask the server to enable or disable the is kinematic value of a cube. You have to turn on is kinematic, because if you don't have is kinematic on, the box collider and the rigid body of the grabbed object will still function, and in the process of moving it across the network, it'll constantly bounce around your hand. If you're not a server, then return if grabbed object try get out network object net obj dot get component rigid body is kinematic is the value. So you could either set or reset it. And then, so when would you want to do that? When you grab the object, you need to turn on the is kinematic. So now we're going to set is kinematic server RPC at the grab enter event, net obj true, and then when you release it, you want to do the same. So for that, we need to have the network object ID. So now we need to add this to the avatar select grab exit event hub, and so net obj false. So now we turn it off. So let's save this. Then remember, we need to these two functions are called from the XR grab event handler. So let's uncomment this. All right, so we see that we get an error message, and I think it is because this should actually not be the network player. You see, it should be the network object. We need to add unity.net code. So let's fix that here as well. It was autocomplete was a little bit too enthusiastic. Great, so now that no more errors. If you get humanoid network player, the second parameter identifies which hand. So if it's true, it's the left hand. If it's false, it's the right hand. So the right ones obviously need to be false. Let's make sure we make these false. So this is all done, but at this point in time, we haven't told the server yet to run the server RPC. We've defined the server RPC, but the RPC has never been called yet. And we'll do that from the update function. And all the way at the end of the function, if the third P toggle is on, only in first person mode, we will check if the AV left grabbed object, if that exists. If it's not null, then we can do a server RPC call. And with what? Well, with the AV left grabbed object. And we want to send it to the AV left position and rotation. And now we need to do exactly the same for the right. So let's copy paste that. AV right grabbed. Then we move the AV right grabbed object to the AV right position and the AV right rotation. And this, by the way, should be the AV left rotation. So this is what we're doing in this space. Fantastic. All right, we go back to Unity, and then we go to the XR origin, select all the direct interactors, just to be sure. We want to make sure that the layer where they're defined in is the Grabbables layer. We got those, and they also have a sphere collider. So let's make sure that in the layer override include layers, we will do the Grabbables. So you will only be able to grab the Grabbables layer. So the first thing that we're going to test is we're going to test in USB mode. So we join in host mode, and we only have done the first person view. You should still see the avatar behind me. So let's move over to the table. And yep, I can now pick up cubes and throw them in the air, and they will bounce back, and I can bounce to each other. So that's all great. So yeah, this all seems to work. Great. Stop running, and we'll do Control B, pause for a second, because it will take a minute or so. All right, so that's now completed. Let's run the host locally. I'll start the host here. I'm switching to scene view. I'll put the camera here next to the table and zoom in a little bit. And I'm going to join with my headset. So yeah, maybe I'll just go to the other side of the table. You can see me there. So I'll pick up this box here, and you see me carrying the box and dropping it down. You see that there's a bit of a glitch, right? Because we haven't fixed the third person view yet. But you can see that I can actually move up a block, and I can actually pick up 2 blocks and throw them away, stack them on top of each other, and well, whatever. We can do all kind of things. Right, so that all works perfect. And now let's go to third person view, because that is another grab that we also still need to implement. Okay, back in Unity. Let's go to prefabs and then a humanoid avatar, a left and a right arm IK target, because those are the ones that for the avatar we want to use to attach the cubes and to create grab detection. The first thing we want to do is let's select both the right and the left arm IK target objects, and we'll add components, box colliders. And we'll make sure that this trigger is on. Center for both of them will be 1, 0, 1. So you see that they now extend over the hands. And we'll make the size 1, 2, 1. So they now have both a box of the size of the hands. Those are the green boxes that you see there. And in the include layers, we want to make sure that this includes the Grabbables layer. And the exclude layers, we want to have everything excluded except the Grabbables. So now we need to do is we need to have collision detection on the hands, and we need to ask the server to have the object follow the hands. That needs to be implemented in the avatar itself. So for both of the left and the right arm IK target, we will now create a child object. So let's create an empty child. We'll call that attach point, and we'll do the same for the left arm IK target, attach point. In the Unity editor is the attach point. We will move those slightly under the palm of the hand. So let's move it a little bit over there. So that means that this is the place where whatever we grab will ultimately end up, and realize that the cubes that we create have a certain size So otherwise they would extend into your hands, and you can play around with that a little bit so that it works well. We'll have the same for the left attach point. So let's go to the right. And so we'll move that a little bit to the right and then a little bit down. Those are the attach points. Great. And you can fine tune it as you want. So again, we select both the right and the left arm IK targets. And with both of them selected, we're going to add a component and we call that avatar XR grabber. And so that's a new script. Let's create that. And let's move that from our assets into our scripts folder. And then we'll double click on the avatar XR grabber. And so the first thing we want to do is we want to create, as always, a few variables. And we want to capture the input actions. And we'll say grab controller action. And we want to have the grab hand action. So these are inputs that we want to grab from either our controller or our hands. Let's make sure we include the input system. Yep. Then we want to have a Boolean that defines whether or not we are in a grabbing state. And then we need a network object, the grabbed object. We need to have network behavior. Otherwise, the network object doesn't exist. Include Unity netcode. Then we want to have a transform. And why do we need that? We want to have the attach point captured somewhere. Third person toggle, so we can check whether or not the first person or the third person toggle is enabled. Okay. Good. So in the start function, so remember, this is running from the avatar, and therefore you'll have many of these instances running at any given time on your VR PC or glasses. So we want to make sure that we only do this if you're the owner. If you're not the owner, then you need to return immediately. What we now do is we look at the current transform. If that is left arm IK target, then grab control action is game object.find, camera offset left controller. And within that, we want to find a component called action-based controller. Let's include the interaction toolkit. And then from that, we want to have the select action, and then we want to have the action. So now we're in the grab controller action. We want to identify, is the action button pressed, yes or no, from the controller. If you would have grab hand action, checks whether or not you are pinching with your fingers. But in this case, we want to find the left hand, transform, find direct interactor, get component, action-based controller, the activate action, dot action. In case of using your hands, you want to get the activate action, which basically means you're using a pinch. If you want to use the full hand grab and not the pinch, you should have the select action. So that is that one. And then I guess what we want to do here is copy paste all of this and do the same for the right hand. If this is the right arm IK target, you want to obviously find the right controller, and for the grab right hand and the direct interactor. So that is done. So, and finally, we want to do a third P toggle is game object.find camera position, the toggle dot get component toggle, and this will allow us to get the status of the toggle button. We also need to do something with the attach points, otherwise it will never know where or when to do something. If grab control action not is no, or grab hand action not is no, creating a bit of a mess. Say attach point is transform find, so at least where we know where to attach this thing to. If either the control button is clicked or the hand grip is identified, we will identify the attach point in this particular object, which is either the left or the right hand IK target. So now let's go into the update function. We are going to do a number of checks first. So if you're not the owner, then let's return, because we don't want to do anything if this is not your avatar. Also, if you're not in a grabbing state, then also return. We only want to do updates if we're in a grabbing state. If we're not in a grabbing state, you don't want to send any information to the server. And also, if not third P toggle, then also you want to return. So we only want to do this for 3P mode. Now we get the inputs of the trigger or pinch. Load X is grab control action, read value, and what we want to read there, we want to read a float. And if we do the same but then for the hand we also want to read a float. So if the sum of these two is 0, then we are not in a grabbing state. Grabbing is false. debug.log 3p release grabbed object network object ID. Else, if we're doing now, we want to do some RPC call. So let's try to create that first. Server side. So this is executed on the server side. So we'll do a server RPC, public void, move my grabbed object. And obviously this is a server RPC, so it needs to end with server RPC. What do we want to give there? A network object reference, grabbed OBJ. We'll ask for a factor 3 position, and we want a quaternion rotation. If you're not a server, very similar to the first person solution, we return if grabbed object try get network object dot netobj transform position is position. So again, this is exactly the same as with the first person, and netobj.transform.rotation is rotation. Okay, cool. And then we do a debug.log client move object netobj.network object ID to position netobj.transform.position. So that is completed. And now we also want to do something similar. We can create a server RPC, public void set is kinematic server RPC. And so we want to do the same, grabbed object. And in this case, we only want to pass on a Boolean value. If not is server, then we return if grabbed object try get out network object netobj the netobj get component rigid body is kinematic is the value. So we're basically pushing the value of is kinematic. So now we have the two server RPCs. Let's go back. Something we want to do here with inverse kinematic. So grabbing is false. We're no longer grabbing, so we are sending false into the server RPC. So re-enable is kinematic. And then finally, let's go to Unity. On the box collider, for the right and the left arm target, we entered is trigger. So that means that as soon as the box collider now collides with another object, is trigger will go. So we can now start creating an is trigger function. So that would be a private void on trigger stay. This is a standard function that's available. Again, if I'm not the owner, return. And if I'm grabbing, then you should also return. In the on trigger stay state, it actually means there is a trigger situation. So as long as you're grabbing, you don't want to change anything. If not third p toggle is on, we also want to return. So we want to do something very similar again. We'll copy paste from our grab or trigger. But now we say if x is bigger than 0, that means that we are grabbing. So grabbing is true. Grabbed object, that is other dot get component network object. Then we want to set is kinematic server RPC. Grabbed object true. Grabbing, so let's turn on is kinematic to avoid bouncing. And then we want to do a debug log. Repeat grabbed object network object ID. So I'm getting a debug log message. And then what we then do to do in the update function, if x is not grabbing, then obviously we will switch off because we're not grabbing anymore. But in the other situation, we want to say, well, we obviously need to move my grabbed object server RPC, the grabbed object. And where do we need to move it to? To the attach point dot position. And we want to move it to the attach point dot rotation. So if we're not grabbing, then we mark grabbing as false and we turn off in kinematics. But if we are grabbing and we haven't released the buttons yet, we're going to ask the server to move the object to the attach point position. All right, go to the humanoid avatar, open the humanoid network player script. And so now we want to add a couple of methods here before the server side grab. Function switch fp3p for demo purposes allows switching between first and third person. So we're saying if third p toggle is on, if that is not the same as the f3p toggle, so basically we have a state change, we want to call some functions. So let's define those first. They want to have a couple of functions for grabbing. So let's call that void switch mesh renderers pool of value for each var x in transform get components in children. And we want to see all of our skin mesh renderers in our avatar. We want to set a value. So basically what this does is within our transform, so that's the avatar, look at all the components in there that have a skin mesh renderer and turn them on or off. And I think I forgot insert x.enabled is true. And so we want to do something very similar for two other functions. Switch avatar XR grabbers. And now we're looking for avatar XR grabber. That's here. We also want to enable and disable that. And then the last one we want to do, switch the XR direct interactors. So for X in my XR cam, so in the XR origin, where are the XR direct interactors? And we want to also enable those values. Now in the switch FP3P, so I want to turn off the mesh renderers if the first person toggle is off, and then switch avatar. XR grabbers, very similar, so that also needs to be in the same way activated. And now the XR rig, you want to do it in the other directions. Switch XR director should be the other way around, right? What you're basically saying is turn on off. This also turn on off, and this is the other way around, so this is turn off on. And then we want to return true, something changed, and then in this case we want to return false, and then hopefully should also take away the error message, no state change. So that is done. Obviously we want to start detecting new state changes, so this needs to be added, right? So now we're setting the internal state of the third P toggle to the actual state again, and we can then detect whether or not this toggle was changed. And then last but not least, we need to call this switch statement. So where do we do that? Update, and just before we go into a major switch, grab if switch fp3p, then debug.log change fp3p state. Right, so let's save this. Then the last thing we need to do, let's go back to Unity. The first person offset here in the humanoid network player. In previous episodes, we put the avatar a little bit behind the XR origin, but now because we've turned off the mesh renderers, we can just put it at exactly the same position. So that hopefully avoids this weird glitch that we saw earlier in our testing. All right, so now let's test it out. We will press the play button. First, we're going to try USB mode, the host button. And so this is still the same. I can still grab with my left and my right hand. Awesome. And now I switch to third person. Cannot pick up anything, but now my avatar can actually pick an object and actually pick an object with the other hand as well. Throw that away. Whoops, sorry. And throw that there. Yeah, that seems to be working. Awesome. And you see there in the debug that if I'm moving, the server is updating the position over the network. All right, so let's see if we can now run this in standalone mode. So let's do a Control B and build it. It will take a minute or so to build. So the host is in host mode. You see me standing there, at least as the host. And so now I'm going to join as a client. Let me stand over here. So I'm picking up the objects with my controllers. That works. This works as well. So now let's move back and switch to third person mode. And you see my avatar again here. So I'm in third person mode. I can pick up the object as well and throw it on the table with my left hand. Pick it also up. You see it's moving there. I can stack it on top. Whoops. So yeah, that seems to be working. Fantastic. Let's see if I can put down my controllers and using the hands. See if it can pick up. No, you see, the hand grab or pick is just not working. And I don't know exactly why that is, but it looks like that the Android platform doesn't support the hand select activity. Yeah, I can try to grab, but it won't grab anything, right? So you can see me, I tried to grab here. I really need my controller, so hopefully in the next version this will work. And that completes this rather long grab episode, which was a topic requested by some subscribers. I hope this was interesting, and I hope you can use some of it in your own projects. And if you have additional thoughts or ideas, then please let me know. We can always retrofit it in. As our baseline is sort of finished, there are many things that we could do now. And we're really at a zillion junction point where we need to pick which way we want to go. And I would, of course, really like to hear from you guys what you would like to see. I certainly have a lot of ideas myself, but would also like to hear from you. Thanks for watching and hope to see you again soon. Bye bye.